Okay, is this on? I'm gonna check it real fast. See how it is.
There.
Trying to go see how it is. Uh, I'm gonna send it to myself through email, and then we'll get started on studying for the AP exams. So I have calculus tomorrow, and then I have physics, and then I have AP Lang, and then I have AP Physics, which I'm worried about. So that's when I think I'm gonna grind. I think I'll do. Yeah, I'm gonna probably do some physics right now. Okay. Okay. Perfect. Sounds right. Okay, so I think we'll start with some physics. I'll do some practice problems. Well, first I'm gonna look at these AP exams, which I did as a mock, and I didn't do too well on. And I think I'm gonna do the again. I'm gonna do some dynamics and see if how I do and stuff. So it says a ball of mass M is suspended from two springs of unequal length, as shown above. The magnitudes of the tensions 10 1 and 10 2 in the springs must satisfy which of the following relations. So this is going up and up. Yeah, it's this one because when you actually do the free body diagram, you have this tension 10 2 and then 10 1 here, and then you have the force of the weight. And when you do the F net, it equals 0. So you would do, since this is the y direction going up, plus T1 minus mg equals 0, and then you add ooh, let me see if I can get this, like, you add mg to both sides, and then yeah. Okay, so we have, it says a 2 kilogram block slides on a 30 degree incline as shown above with an acceleration of 2 meters per second squared. Which of the following diagrams best represents the gravitational force W, the frictional force, and the normal force to act? So I want to draw it myself instead of looking right there. So the friction is going against the object. Actually, no, it's letting it slide. It would be like, I always get these like confused, and that's something that's like when we know that the normal force is just like this. So from this, we can actually cut out this one, and this one. Well, yeah, friction. When you slide down something, and we go up, try to incline, like a little incline, so I can like actually visualize it. I don't even know, to be honest. Whatever, like, nah, that doesn't work. Oh, here, I got easier, go like harder. I don't know what I mean. Sorry, I don't know if I'm making that much sense, but yeah. Which will finally increase the magnitude to acting up. And so now we actually need to solve. So we have F net equals A. We have the friction, and then we have FIP. So because the normal force and the force of the weight actually cancel each other out. So we can just do K minus FIP equals NA. So we have mg times cosine of 30 minus mg sine of 30 equals ma. So we can cancel out the m's on both sides and then actually solve it with a calculator. So then it would be, let's just do 10 for 9.1 cosine of 30 minus sine of 30 times 10. We get the acceleration. I didn't even need to solve it because like the only ones that make sense is, okay, so it's 20 newtons down the plane and then 16 newtons up the plane, and then the other one is the other option, which is B, is 4 newtons down the plane and then 4 newtons up the plane. And for C, it'd be 0 newtons down the plane and then 4 newtons up the plane, and then the last option is 10 newtons down the plane and then 6 newtons up the plane. So it's actually B, because those are the only two that cancel each other out, and the force, normal force, and the force of weight cancel each other out. So I don't know what I was thinking here, but I think I probably got it right too for this one. So, okay, it says when the frictionless system above accelerated by an applied force and makes the tension between is. Okay, let me first do the first free body diagrams. I'm not gonna completely, but okay, when the frictionless system above is accelerated by an applied force of magnitude, the tension between. So we can do F net. This is kind of hard, to be honest. I think this one, since I'm just guessing, so I'm gonna put a little guess sign here. Since these two cancel out, I'm just approximating. Like, I'm just saying that MA would equal F, but I'm not really sure. So the next question is: a ball falls down straight down through the air under the influence of gravity. There is a retarding force F on the ball with magnitude given by equals BM. F equals B F V. Sorry. Well, F equals B times V, where V is the speed of the ball and B is a positive constant. The ball reaches a terminal velocity of 10 times the magnitude of this acceleration at time. Okay. Ball falls straight down. Let me go really fast. Where V is the boom and B. The ball reaches a terminal velocity after time t. The magnitude of acceleration at time divided by 2 is, okay. I feel like it's 10 because it's the force of gravity is always present on the ball. So let's move on. I think I mean, I stapled it pretty wrong. This is the MIT workbook for AP Physics. I saw it from this guy. He said recommend this, so I'm just doing it because I really need to do good in this AP test. So a block of weight W is pulled along a horizontal surface at constant speed by a force F, which acts on an angle of theta with the horizontal shown above. The normal force is exerted by the magnitude. So the force of the normal force right now is mg plus F sine, I think so, of theta. And it's greater. It's greater because being added plus this is weight. You add on F sine of theta, you get plus the actual weight. So you get more. So another one is this. A uniform rope of weight 50 newtons hangs from a hook, as shown above. A box of weight 100 newtons hangs from the rope. What is the tension in the rope? Okay, so okay. First, a normal force of weight newtons hangs from a hook, as shown above. Okay. Box of weight hangs from the rope. Okay, so this is 50 newtons, and this is 100 newtons. Okay. Uniform rope of weight. What's the tension? This mass equals 10 kilograms, and then this mass equals 5 kilograms. I'm gonna guess on this one. I really don't know how to approach it, so I'm guessing this one. Okay. So this is when an object of weight is suspended from the center of a mass of the tension at any point. So free body diagram. So we have cosine theta plus ft2. Cosine of theta equals 0. Okay, I'm thinking about this. I'm gonna put this one, but I'm guessing. I'm guessing because the ones that I don't know, I'm not gonna force myself to actually learn them. Like, not right now. Like, I'm not gonna force them to actually get it right now, because after I'm gonna learn. That's what I meant. Sorry. A block of mass 3m can move without friction on horizontal tape. This block is attached to another block of mass m by a cord that passes over a frictionless pulley as shown above. The masses of the cord and pulley are naturally. What is the magnitude acceleration of the descending? This is lowercase m. So we're first gonna draw the free body diagrams. We have the tension, the normal force, and then the weight. tension, and then weight. This is for little m. So then when we do the net force for both objects, we get force tension for this one. Yeah. But it's A equals G divided by 4. You have to do the F net and then actually combine them and then actually just do the plus. Okay, plane 5 meters in length is inclined at an angle of 37 degrees as shown above. A block of 20 newtons is placed at the top of the plane and allowed to slide down. The magnitude of the normal force exerted on the block by the plane is. So there's no mass, so we can't use that. Oh no, yeah, there is mass. So it's 2 kilograms. Oh, just equal to 20 newtons. Sorry, I didn't realize it because the both normal force and the weight cancel out. So after, I'm gonna go up to 30 and then check it, and then I'll do some more problems. I think I have torque. Yeah, I have torque. So we should be able to do that one. I'll check them out real fast. Oops, my fault. Okay. Sorry about that. So it says 3 forces act on an object. If the object is moving to the right in translational equilibrium, which 0, which of the following must be correct? Well, in translation. Okay, so it's definitely A, the vector sum of the 3 forces might equal 0. Equilibrium, it's when it's 0, so we already have that. All 3 forces must be parallel. You can't say must be. So no. The magnitudes, yeah, must be equal to each other. And I think that's it. If not, then we'll see. For which of the following motions of an object must the acceleration always be 0? any motion at constant speed. Okay. A rope of negligible mass supports a block that weighs 30 newtons, as shown above. The breaking strength of the rope is 50 newtons. The largest acceleration that can be given to block by pulling upon it with the rope without breaking the rope is most nearly. So, okay. It says, okay, the breaking strength is 15 newtons. The largest acceleration that can be given by pulling up on it. Hmm. I think it's 6.5. So this math and there's a 20 equals 30. A and 8 equals 6.6. Whatever. Question 14. I mean 14 to 15. Wow. Okay. A horizontal uniform board of weight 125 newtons and length 4 meters is supported by vertical chains at each end. A person weighing 500 newtons is hanging from the board. The tension in the right chain is 250 newtons. What is the tension in the left chain? So uniform board supported by vertical. Hmm. Okay. Uniform horizontal uniform board of weight 125 newtons and length 4 meters is supported by vertical chains at each end. Okay. A person weighing is hanging from. Okay. So you have the combined length of 500 plus 125. And when you divide it by 10, you get the mass of 62.5 kilograms. Okay. So I'm just guessing on this one. I put 250 newtons. So that's what I'm putting. Which also describes where the person is hanging. I think I'll put C right in the middle of the board. So I have this multiple correct. The car of mass 10 grams shown above moves without frictional loss on a level table. A 2 Newton, a 12, I mean, excuse me, a 10 Newton force pulls on the core horizontally to the right. At the same time, a 30 Newton force at an angle of 60 degrees above the horizontal pulls on the cart to the left. Which of the following describes the manner in which this cart could be moving? Select two answers. Cart of 10 months shown above moves without frictional loss on a level table. A 10 Newton force pulls horizontally to the right. Hmm. Okay. Two people are pulling on the ends of a rope. Each person pulls with a force of 10 newtons. The tension in the rope is. So questions that are so simple, but like makes you think. I think zero. The parabola above is a graph of speed v as a function of time t for an object, which is a fun graph bears represent the magnitude f, and the force excited on the object as a function as. Okay. 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 A ball initially moves horizontally with a um, velocity v initial as shown above. It is then struck by a stick. After leaving the stick, the ball moves vertically with a velocity with vertically with a velocity of velocity find, which is smaller in magnitude than v initial. Which of the following vectors best represents the direction of the average force that the stick exerts on the ball? Okay, it's B. Okay. Two massless springs of spring constants K1 and K2 are hung from a horizontal support. A block. Wait, why didn't I share my screen? Okay, that's cool. Yeah, I'm definitely use that for next time. Um, two massless springs of spring constants K1 and K2 are hung from horizontal support. A block of 12 newtons is suspended from the pair of springs as shown above. When the block is in equilibrium, each spring is stretched an additional 24 centimeters, which the fun does. The fun is correct about. Hmm. I'm skipping that one for. A block of mass m is accelerated across a rough surface by a force of magnitude F that is exerted at an angle uh, with the horizontal as shown above. The frictional force on the block exerted by the surface has magnitude F. What is the acceleration of the block? So, okay. I'm guessing on this one. Well, at least I don't know. Guess. 3 blocks. Blocks of mass 3m, 2m, and um and are connected to strings A, B, and C as shown above. The blocks are pulled along a rough surface by a force of magnitude F exerted by string C. The coefficient of friction between each block and the surface is the same, which strong must be the strongest in order to not break. Like they have to be the same strength. The tensions could be 0. A block of mass 3 kilograms initially at rest is pulled along a frictionless horizontal surface when a force shown as a function of time by the graph above. The acceleration of the block at time equals 2 is so time. I really don't know. A student pulls a wooden box along a rough horizontal floor at constant speed by means of a force P as shown to the right, which is funny must be true. A 10-kilogram box shown in the figure to the right is sliding to the right along the floor. A horizontal force of 10 newtons is being applied to the right. The coefficient of kinetic energy between these boxes when the box moving is okay. So this one we checked to math. Alright, acceleration equals -1. Assume the objects in the following diagrams have equal mass and the strings holding them in place are identical, in which case will most likely break. This one no, because it's gonna be zero. This one. Okay. We're about to get to 30. We'll end it. I'll check, and then we'll see if I do another one. I need to wait for my mom for dinner. 2 blocks of mass 1 kilogram and 3 kilograms are connected by a string which has a tension of 2.0 newtons. A force F acts in the direction shown to the right. Assuming friction is negligible, what is the value of F? Because 50 kilograms of stands on a scale no other on the internet. The scale weighs approximately. This is it for now. I'll do another one in a bit.